close. Let's see. Okay, go live. And 3, 2, 1, we are live. Okay, we are live. And awesome. Actually, I have no visibility right now of what you guys are seeing. So I am just going to open up the. Give me 1 second. I am setting something up from my side here. Okay, that works there. Give me 1 second. I need to see what you guys are seeing so that I can adjust my screen. So I am opening that up on my system here. How do I open this in app here? Yeah, 1 second. Okay, seems like I'm streaming. I am streaming at 720p. Quality seems to be okay. Quality seems to be okay. I wanted to see the live chat. Why am I not able to see the live chat? Let me see. Yes. Okay, I can see the live. Yeah. Don't worry about my voice. My voice should be audible right now, like clearly now. Wow, I'm sweating. Okay. So yeah, I am visible, it seems, and I can see the chat, and I can hear you guys. No, I can't hear you guys, but you guys can see what I am seeing. Okay. So I'm just going to do a silly thing right now. So this is my uh, like the table that on which my stuff is right now. And on the right side, you guys can see that I'm on a link that has these three switches, right? So who wants to have some fun, right? Who wants to, actually, I'm going to close this one. I'm going to open up a, yeah, why not do this? Just, I'm going to send this link to all of you in the group chat. I'm going to send this link to all of you in the group chat. And then I would like you guys to open up this link that I'm sending you. You will see three switches, okay? So you will see three switches, and all you have to do is turn them on and off. Don't do it continuously. I will disconnect the link in 1 minute, but I want you guys to see what we are going to do today. So I am sending the link right now. I have just sent you guys the link. Okay, open up the link, and awesome. I hope you guys can see what I'm seeing right now, but just do, okay. Yeah. So see, I'm not doing anything. I'm not doing anything, but the lights are turning on and off. So what's happening is, on the link that I have sent you guys, these switches, they, okay, stop. I'm going to disconnect this now. Yeah, so this link will not work anymore. Okay, cool. Not this, what? 11, yes. Okay. Cool. Okay, everything is off right now. Everything is off. I wanted to start with showing you guys what we are actually going to be doing here. So see, there is a switch here. If I turn this on, it turns my light on. And well, let me do one thing. Let me just turn off the lights in my room. Awesome. So I have turned off the lights in my room. I'm not sure what you guys are seeing, but I'm guessing everything would be very dark. Let me see. Yeah, everything would be very dark. Now, I have a lightsaber here. Do you guys know what a lightsaber is? It's from Star Wars. It moves. Yeah. So what I want to do is I want to turn this lightsaber on and off. I have the second switch here. If I click on, see, my lightsaber turns on. And if I turn it off, my lightsaber turns off. And then the third thing is an LED here. I'm not sure if it's clearly visible, but there is a yellow LED on my circuit board that turns on and off with the third switch. Ignore the third switch, but see, this one turns my lightsaber on and off. And then this one, wow, that's blinding. This stop switch turns my bulb on and off. Okay, let me turn back the lights in my room and we will begin with our session. Cool, let's close this and then let's close this. Yeah, let me just turn on the lights in my room. Okay, I'm back. I have switched off the link that is going to be accessible to all of you. The link with which I am working right now is a temporary link, is a local network link. So this link you guys will not be able to open at all. I had given a different link to all of you guys on the chat. I have closed that link. I will send out another link after some time. Don't worry about it. Okay. So what we are going to do today is we are going to, as I showed you, we are going to learn how can we control uh, our home, the lights, the appliances in our home. How can we turn them on and off using through the internet? Okay. So before we begin, in the description of this video, in the description of this video, I have sent a link of a Google Doc. You will find in the description of the video, you will find that there is a Google Doc link. Control. I'm just sending this in the chat as well. Okay. Open up this link. This link contains everything that we're going to cover today. All the code, all the materials needed, the circuit diagram and everything. So you guys will be able to follow everything that I'm saying because I won't be writing all the code. I have already written all the code. I will be explaining what code I have written and you guys can copy paste the entire code that I have written and make the edits. I'll tell you where you guys will need to make the edits to make it work for your home. So you guys can do that and then you guys will be able to control everything in your home through the internet with the right circuits, okay, conditions. All right, cool. So let's start. Is anyone's stream laggy? I don't think I'm not lagging from my side. So someone is asking if is anyone's stream laggy. Yes, someone said no. Okay, cool. So let's begin. So what are we going to what parts are we going to need and what are we going to do with those parts? So I'm not able to show it on my table right now, but we are going to need a circuit board called ESP8266. And ESP8266 is a circuit board. It's barely around yeah, 200 bucks. So it's a very cheap board. It connects to your Wi-Fi. It can work as an it is a really good circuit board that works amazingly, that connects to your Wi-Fi and works amazingly with home automation projects, smart home projects that we are going to do today. So we are going to be using this board, an ESP8266. All right. So ESP8266, and we are going to be using this board. And you will notice in the document that I have shared with all of you, I would like to. How do I preview this thing? Yep. Let me zoom it up. Yeah, and close this thing. Okay, so we are going to be needing an ESP8266, and you can see in the document I have added an image that shows all the pin diagrams. So this is very similar to an Arduino. we are going to be using the same coding platform as Arduino's. We are going to be using an Arduino's IDE to code our program for this board as well. So this board, just like an Arduino has a pin, has multiple pins, and those pins can be modified to do different activities. Similarly, you can see. So this is my Node MCU board, and you can see on the left and right side, the pins are already labeled. So on the when you get the circuit board, you will be able to see this D0, D1, D2, all of these things printed on the circuit board. So you will know which pin is called D0, and here you will know that what D0 can do. D0 has a, so let me tell you about D1. D1 can work as a clocks, can work as a data pin, and can also work as a clock pin. Uh, there is a, yeah, there are, I mean, don't worry about all of this. Just I've added this pin diagram so that you will know what pins I'm referring to for today's class. Okay. Yeah, I know you guys don't have these things. That's why I have given you guys the entire document for today, because this will be accessible anytime you want. Uh, Whenever you guys buy the parts, you just need one part. That's Node MCU. That's all you need. And another thing called relays. I'll show you guys how relays work. But yeah, two things. That's all you will need to make to make the projects. You'll need a Node MCU board and some things called relay. I'll tell you what a relay is later on. Cool. So in the document you'll see, yeah. So we have the Node MCU board, and below that we have the circuit diagram of what we are going to be doing today. So a circuit diagram of the circuit that we have to, how to attach the wires. Okay, so as you can see today, so I'm using three pins of the Node MCU board of this ESP8266 board. I'm using three pins. They are called D1, D2, and D4 on the pin on the board. All right, you can see here as well in the circuit diagram, and I'm attaching these three pins to three appliances, three diodes, whatever you want to attach. So the bulb that you saw me holding, that was attached to D1. My that lightsaber, that was attached to this D2, and I have another LED attached to D4. Okay, so oops, I made a mistake. Cool. Uh, yeah, so I have my circuit diagram here. So D1 pin is attached to one of my appliances, D2 pin is attached to another one of my appliances, and D4 pin is attached to another one of my appliances. Done. Once you attach, and then there is a ground here. One of the pins is called, there are lots of pins called ground. Just select any one of those pins and connect your appliances with a small resistor here, and that resistor can end at the ground pin. Okay, so for to connect all of this, I'm using, okay, uh, let me show you like this. Let me show you on my phones, on my circuit board. So I'm using my phone's camera to show this. I hope it's all of this is visible. All right, so what I'm showing is so we are using something called a Node ESP8266 board. Okay, and I'm giving it a power supply through my Arduino. I don't need an Arduino to give it a power supply, but for now I'm giving it a power supply through my Arduino. You can directly give it a 5 volts battery. You can directly connect this circuit, this Node MCU board, to a 5 volts battery. I don't have a 5-volt battery. I have this 9 volt setup here. So I'm using this 9 volt to power my Arduino, and on my Arduino there is a pin using which I can output 5 volts of power. So that 5 volt is what I'm connecting to the Node MCU board right now. But you guys can directly use a 5 volts battery if you want. All right. Don't worry about the Arduino here. Arduino is completely unnecessary in this example. So we're using another something else called a breadboard. You see all of these wires, they are attached to a breadboard, this a white colored board with all the holes in it. It's called a breadboard. Okay. So what is the specialty of a breadboard is we don't have, it helps reduce the amount of wires we need to use in a circuit. Uh, because it has a lot of internal connections already made. Uh, Let me come back to the document. So yeah, on in the breadboard, whenever you get a breadboard, you will notice that on a breadboard, on the edges there are two lines, red and blue, and then your breadboard is having some other dots, some other holes inside the board. Okay, so what a breadboard has is these red and blue lines are connected vertically in the from behind. So if you connect some, like, let me show you. So if I connect my ground to this blue line, the pins with the ports here with labeled as blue lines, then that means that all these holes here, they are grounded. So when the resistor here is connected to these pins, it automatically means that these points are connected to the black wire here. Okay, that's the benefit of using a breadboard. So what it means is, like, this orange wire here is connected to this point. This point is inside my breadboard. Inside my breadboard, all the points horizontally are connected with each other. So if I attach a wire here and then my LED is connected here, uh, because of the internal wiring of a breadboard, this hole, this point of the LED is connected to the orange wire by default. Okay, if you inside the board, everything is connected horizontally, and outside with the red and blue wires, everything is connected vertically. Okay, so we use a breadboard to reduce the wiring. Okay, um, no, nobody will get electrified. It's really, trust me, it's really easy to make. I'm just don't worry about what everything here. I'll show you how it's really easy to do. Okay, so cool. Now we come to the coding part. Okay, so for the coding part, you can see I have already attached the entire code that we are going to be using. I will be showing you guys what the code does, how the code does all of this. So before we go to the code part, uh, you'll have to install these two libraries. So just remember, I was showing you guys for the robot car that there are no, the Node MCU board costs $200. It won't cost you anything around 2000 bucks. Everything electronics, individual electronics parts are very cheap. You know, somebody was mentioning it will cost around 2000 bucks. I'm just saying that the node and these circuit boards are very cheap. Okay. Uh, Cool. So yeah, just like for our servo, remember when we were coding for our servo in our previous session, we were using a library called servo.h. We had written a line of code that said include servo.h. Yeah. So servo.h is a header, is a library that comes pre-installed in the Arduino's IDE. There are some libraries that we don't have access to, that are not already installed, but we need to install them. So to do that, what you'll have to do is, in this document, uh, there are these two libraries links. You download the zip file. Okay, download these two libraries zip file, and what you'll have to do is open up your Arduino and go to your manage libraries, and you'll have to add the zip files in your manage libraries here. Okay. Or yeah, sorry, sketch, include library, add zip library. Yeah, this is what I wanted to show. So these two are zip files here in the document. Download these two zip files and then open up your Arduino's IDE, and then go to the sketch menu, select include library here, and in the add zip library, click here, and then select the zip files that you have downloaded from here, and they will be added to your Arduino's IDE. Cool. So this part is done. Uh, Now let's come to the code part. So code. I'm going to show you guys in this document here, because this document is something you guys all have access to. So what we are doing here is, first of all, we are creating a website. We're creating a very simple website that has three buttons. Okay, and yeah, so we have these three buttons. Let me, yeah, so oops, yeah, cool. So we have these three buttons, and these buttons can turn on and off. When they are off, the buttons are gray. When they are on, the buttons are red. Okay, so this is HTML, basic HTML, CSS. Most of you know how to do basic HTML CSS. I'll show you the code of it, but this just involves adding three buttons that when you click on them, they turn on, then they turn off when you click on them again. Okay, and then what we are doing is we are creating our own web server where this is giving communicating the buttons when you turn on and off. It sends an HTTP request. One second, my Chrome's window. Yeah, yeah. So I'll show you. I'll show you. Let's start with the let's break down the code from the very beginning. Okay. So in the code, what all you have to do is copy paste the entire select the entire code, copy it, and open up an Arduino's IDE, paste your code here. Okay, paste the code that is written in the document, and I will tell you where you guys need to make the changes. Okay, so let me show you now. In the code that is mentioned in the document, you will notice that at the top, there is a line that says enter your Wi-Fi name here and enter your Wi-Fi password here. So this is where you will just have to change and write your Wi-Fi's name and your home Wi-Fi's name and your home Wi-Fi's password. So Node MCU connects to 2.4 gigahertz frequency, doesn't connect to 5 gigahertz frequency. So like my Wi-Fi here, I have 5 gigahertz and uh, another 2.4 gigahertz, but my laptop is connected to 5 gigahertz. I have to, there is another network available here that is 2.4, yeah, 2.4 gigahertz. So uh, and its name is Netwit 2.4G. So I have written the name here as Netwit 2.4G and the password of my Wi-Fi here as that. Okay. So whenever you copy paste this code, you'll have to make this change here. You'll have to change this thing to your Wi-Fi's name and change this thing to your Wi-Fi's password. All right. Okay. So let's understand how the code works. Let's understand how the code works. So what we have done is I have included three libraries: ESP8266 Wi-Fi. So there are three libraries we're using. You just include the hashtag include greater than less than symbol and the ESP8266 Wi-Fi.h, ESP async web server.h, and ESP async TCP.h. So we installed these two libraries from the zip file, and this you can get from the manage libraries option here. So in the manage libraries, you'll have to search for ESP. Yeah, here in the library manager, you search for ESP8266 Wi-Fi library. That library helps your circuit board connect to the Wi-Fi. Okay, here you search for ESP8266 Wi-Fi, and it will give you the option of the ESP8266 Wi-Fi library, and you can attach that. You can download that. So it's already installed in my thing right now, so I don't have to do that. So three libraries we are using, write those the way I have written here. After that, Wi-Fi's name, Wi-Fi's password in two variables. We are storing our Wi-Fi's name and Wi-Fi's password in two variables called SSID and password. Okay, and we are creating two variables called output and state. Why are we creating two variables, this output and state? Because when our website is running, whenever we turn a switch on or off, it has to communicate to our server that which switch, which which pins data is supposed to change. Pin number 5, pin number 4, or pin number 2. Because right now I have connected my circuits to pin number 5, 4, and 2. Okay. Okay. The diagram here is 4, 2, and 1. I have connected everything to 5, 4, and 2. Okay. So, oh no, 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 no. D1, D2, D4. You can see here. D1 is pin number 5. D2 is labeled as pin number 4, and D4 is labeled as pin number 2. So 5, 4, and 2. Okay, that's why I was saying 5, 4, and 2. Yeah. So yes, we need our website needs to communicate to our board that which pin is supposed to change its state from on to off or off to on. Okay. So what you have to do is we are creating two variables. One is called output and one is called state. Okay. So output is basically keeping track of which switch are we turning on and off, the pin 2, pin 4, or pin 5. And state is basically is the switch on or off, keeping track of that. All right. And then we are creating a server object using this line. That's a sync web server, and giving the name giving the server name as server at port 80. Just copy paste these lines as it is. You guys don't have to worry about the entire code of it. Okay. You guys really don't have to worry about anything as long as you have the circuit board and Wi-Fi running. Just copy paste type the Wi-Fi's name and password here. I'm explaining the code now. So after that, now I think my camera turned off. Let me turn it on. I have to. I think I'm not focused. Oh, I'm focused. Cool. Okay. So as I was saying, after you create the server name, then we create our website. Okay, we design the website. Does the website look? So to do that, we are creating a variable called index.html, and then inside that, so I'll if you go to scroll down the document. So let me go through it one by one. So we entered our Wi-Fi's name and password. We created two variables called output and state. Then we started our server. We created a server object at port 80. After that, we are building our web page. So you'll see below that I have written in the syntax of the line. This is how it. This is what you have to write. And then you see this double slash here. This is where you will write your entire web page's HTML code. You can do it in a different tab as well, but don't do that right now. So right now, what you can see in my code here as well, I have the entire HTML code or CSS, JavaScript, all the code here inside these in the index HTML variable. Okay, so here I'm writing the entire HTML code. So yeah, the code is very simple. We start with a doc type HTML tags, HTML tag, head tag, give your website a title. So my website's title is Netwit's web server demo. And then I have a meta tag here that is going to help adjust the width of the website when I open it on different devices. Okay, the screen's width, it will adjust accordingly. This line just helps it accommodate for different screen sizes. Don't worry about it. And then there is this thing here, this line that okay, this is called a 5 icon on the top. You see these icons. So this website does not have a 5 icon, and whenever a website opens up, Chrome, your browser tries to find its 5 icons. So I'm saying that there is no five icon. Ignore it. Just through this line of code. And then this is the CSS of my entire page. So you can just copy paste that. Don't worry about what I have written here. This is just basic CSS. After the CSS is done, then we come to the body of our page. So what is involved here? We have a title, then we have some heading text and buttons. We have 3 buttons and 3 heading text for those buttons. Okay. Uh, I can change it. So if somebody is messaging that, oh no, my Wi-Fi's name and password is visible, I can change everything here. Don't worry. It's and even if somebody hacks, there is nothing secure. I mean, there is no national security level thing on my laptop. Okay? Don't worry about it. Fine. So we were talking about the body of our HTML page. So as you can see in the body of our HTML page, we have a heading here. Uh, it's called Network's Web Server Demo. So we are defining in our body an h2 tag and saying Network's Web Server Demo. You can give it your own web page's name. All right. And then we are not writing the code of our buttons just below our h2 tag. We are adding a placeholder like this. So we will call this placeholder uh, later on in our code and tell it to replace this placeholder with the current state of the buttons, whether as in draw three buttons with them being on or off, however they are. Okay. So for now, we are adding a placeholder here. And then there is a JavaScript that sends HTML requests of whenever you change the state of a button. Whenever you turn a button on or off, uh, this function here, this function here, it sends an HTML request to your server that the state has been changed and update it. Okay, update in your database. So don't you guys don't have to write this thing, just copy paste the entire code. It will work for you guys. Ignore it. Okay, so now we have to replace this button placeholder with the three buttons. So for that, now our HTML page is done. So after that, I'm creating a function that is drawing my buttons. Okay. So right now I'm drawing three buttons. So for those three buttons, you see I have these three buttons here, three lines of code here for three buttons. So if you don't want to have three buttons, you just want to draw just one button, delete two buttons here. If you want more buttons, then all you have to do is copy paste the last line of this button code. Okay, so let's say like my room has 1, 2, 3 lights and one fan and then some plug points. Okay, so I'm going to connect my three lights and one fan to my board, to my on my website. So it will need four buttons for those. Okay, so then all I have to do is first of all decide on which pins are you going to connect your appliances to. So right now I was using, as I was saying, I'm using pin 5, 4 and 2. So what I can do is I can use pin 5, 4, 2 and 14. Okay. So then what I would do is if I'm using pin 14 as well, this D5 pin for a fourth appliance, then all I have to do is I have to just copy this button's text, press enter, paste it. Okay. Paste it. So now I have another line of button code here. Another button is supposed to be created. And what I'm going to do is here, all you have to do is change. So here, after that, when you say button plus equal to, after that, we are displaying the text on top of the button. So this output GPIO2, I'm just going to change it to 14 to know that will tell me that the next appliance I'm connecting to pin number 14 of my node of my ESP8266. Okay, and for my website to keep track of it, I'm giving it an ID, and that ID is stored here. So give it an ID of 14. That's all you'll have to change depending on whichever pin number you're using here. Okay, so you have pin number, see 1, 3, 15, 13, 12, 14, 2, 0, 4, 5, 16, and then 9 and 10. These so Node MCU has 16 GPIO pins. Those are the only pins we can use. If you want to connect more than 16 appliances, then get another board. Okay, but I'm guessing you guys will not be using more than 16 appliances at a time. So one board is going to be enough. Now what I am doing is, yeah. So if you, appliances turning on and off, that's all we are doing. So however many buttons you want to add, just copy paste the buttons line of code and then So whenever you copy paste, just change the buttons text. Okay, so you can have anything here. So I know that my first button is connecting to my bulb. Okay, the second button is connecting to my lightsaber, so I can have it, I can give the text like that as well, lightsaber. And then the third button is a simple LED that I have. Okay, so headings can be any, the buttons text can be anything that you want. Don't worry about, I was just displaying it as 54214 because it helps me keep track of which pins I have already used of my circuit board. Okay, so pin 14, and then there is an ID here, so change the ID whenever you copy paste the line. And then there is another function that we are going to create later on, called output state. So in that output state, you have to pass on the ID of the pin that you're defining here. So if whatever ID you define here, that ID you type inside the output state brackets. So 14. Two changes. Copy paste the buttons line, and then uh, change the ID number and change the output number inside the output state. That's all you'll have to do from your side once you copy paste the code. Just understand what this is doing. This is creating a button with the text, and then whenever we are changing the state of the buttons, the our this HTML, our script here, JavaScript here, the JavaScript function here, it sends an HTML request of to update whatever value of the buttons we have now. Okay, 0 or 1. Buttons are turned off. This its state is 0. Buttons are turned on. Its state is 1. Okay, awesome. Okay, so created the buttons, and then because you saw there was an output state function that we were defining here. This is the function output state. So we have to create that function. What does that do? That checks if the button is on or off. Okay, so we are saying that this output state, it takes in the pin number and it reads the value of the pin number. If the pin number is, if the data at that pin is high, then return that the button that it's already checked. Okay, the button is turned on. Otherwise it's false. Return an empty string. Okay, after that we come to the setup function in our Arduino's code, the default setup function. Inside that, there is just one line here that you don't need this line. This basically starts an output monitor here. You see this output monitor that shows me what my circuit board is doing and what is turning on or off. Okay, so when it was connecting to Wi-Fi, this basically acts like a console. It initiates a console, just like in your JavaScript editor you have a console. This line here initiates a console. This number here is called baud rate. It's similar to refresh rate. It's not exactly refresh rate. Uh, don't worry about it. Just write this, and whenever your monitor starts, you have to select this number that you have written here, 115200. So select 115200 here, and it will show you the exact thing happening in your circuit. After that, we are defining that which pins we are using of our node MCU. So we are using pin number 5, we are using pin number 4, we are using pin number 2. So we are saying that all three of these pins are output pins. Yeah. If you were using more pins, you would just copy paste the pin mode line and paste it here, which let's say I'm adding additional pin number 14. So pin number 14 is output, and then set the pin by default to off. So digital write pin 14 to low. Low means the pin is off. That's all you'll do. Whenever you add new appliances, whenever you are adding new instruments to your circuit board, just pin mode and pin mode set to output, and turn the pin off by default when the code starts running. Okay. So you have that, and then I'm saying I'm telling my circuit to start the Wi-Fi, connect to the Wi-Fi, and while it's not connecting, print connecting to Wi-Fi. So you can see that here it's printing connecting to Wi-Fi, and after it got connected, then print the IP address. So it prints my local IP address here on which I can access my website. So you will notice that this is the IP address here that everyone can access. Okay, cool. Uh, this is done, and after that all we are doing is we are turning our server on and we are sending messages through our server, or we are communicating to our server uh, if is the when the switches are turning on or off. So you guys really don't have to do anything here. Just copy paste from this Wi-Fi line. You guys don't have to make any changes in this here. To add any new appliance, add a new button, add a new ID for the ID number for the button. Okay, so like pin 14, output state pin 14, and then in the setup function, define the pin mode of that pin to be output and set it to low. Okay, by default. All right, and then you guys don't have to do any changes here. So I'll tell you what this server is doing. Once we are turning on our server, we are saying that it's getting request. We are sending here. See, in our HTML page, in our HTML code, we are sending it requests. We are sending it HTML request in form of slash update output element ID and state equals to 1 if it's checked. Remember, we are saying that. This output state is checked when the button is on. So if it's checked, then output is equal. We have two variables here, right? Output and state. We have two variables here. So in our HTML request here, you will notice what we are doing is whenever a state is changed, so uh, if the element is checked, if that button is checked when it's on, then send the request of the line. The request format would be slash update question mark output. The output variable is equal to whatever is the ID of the button. We set the ID of the button. It was 5, 4, 2, or 14. Remember those IDs? So we set the ID. So define the ID here. And because it's checked, then the state of the button, we are defining it as 1. Or if the button is off, then for that button, for that element ID, define its state as 0 and send this request. Okay, send this request. So whenever I get the request, whenever my circuit gets the request, what it's checking is we are defining two variables, input message 1 and input message 2. Now I'm saying that if my request has the parameter input 1, parameter input 2, because you'll notice that the output and state variables were defined in param input 1, param input 2 here. So if the request, so whenever we are sending these requests are having these strings here, output and state strings, right? So that's what my server is checking here. So if the request has the values of param input 1 and request has the value of param input 2, then input message 1 and input message 2 will get, I'm telling that store the values of those buttons on or off, 0 or 1, in the input message 1 and input message 2. Input message 1 will store which pin, and input message 2 will store on or off. And then I'm telling my node MCU, the circuit board, to then set the state of my pin of that input message 1's pin to the value of input message 2. As in, basically, if input message 1 is telling the lightsaber pin, and input message 2 will be telling it whether the lightsaber is on or off. Input message 1 variable would be telling either bulb or lightsaber or LED, and input message 2 will be telling on or off. So digital write will set the state of those appliances on or off. So digital write, then we are saying input message 1, basically which appliance. Input message 1 will tell whether it's the lightsaber or the bulb or the LED, and then input message 2 will tell you if it's on or off. So that's what we are doing here. Forget about all of this. You guys don't have to worry about the servo code here or any of those things. We are keeping the loop empty. We don't have to do anything there. All you have to do is to connect more appliances. Just first of all, yeah, type in your Wi-Fi's name and password, and then to connect more appliances, add more buttons, and define the pin as output and set them as low. Just that. Okay, everyone has gotten bored. So I'm going to just show you one last time. Once I complete the code, I have to compile the code and then upload the code. So one upload the code. Let me show this. So okay. So to upload the code, you see my Node MCU has a port here, and there is a cable. Use that and upload the code. Upload the code. Once the code is uploaded, then all you have to do is, yeah, once the code is uploaded, all you have to do is connect your Node MCU to a battery source, and then what we are you will be able to turn your appliances on or off. See, through the internet. This is a local IP, so you won't be able to access that. I have another. Okay, since very few of you are here, so we can try one last thing. I'm going to um, I'm just going to send you guys a link. Let me just check it if it's running or not. I'm temporarily putting my local that website on a link, on a permanent link here. Yeah. So this link, you guys can turn it on or off. Open up the link, and you guys will be able to turn my appliances on or off through the internet. Try it. Oh, you guys can try that out. Open up the link. Uh, See, it will take time to communicate via the internet, but yeah, see, somebody just turned the lights on and off. I'm not doing anything. I'm just sitting here holding my phone. It's what you guys are turning it on and off. Yeah, somebody has turned on this yellow LED here. That's the last. That's the third switch. Somebody is turning this on and off. Somebody just turned my lightsaber on. Because my room's lights are on, so you guys can't clearly see. But okay, I was on the left side. You guys should see it like this. Yeah, somebody is cool. I mean, you guys are getting an idea of how this is, right? Uh, Download the code, install the libraries, connect your circuit. So now one last thing that I wanted to show you. So now LEDs run on DC current. Your appliances run on AC current. Like this bulb here, it runs on an AC current. Okay. So to connect your all your rooms electrical appliances, you don't have to. You cannot directly connect those to your circuit board. Okay. So to connect your appliances, what you'll have to do is you'll have to get a relay board. You can see that there is a relay board here. All right. So relays are basically switches. So relays, you see my bulb here is connected to the relay from this point, and my relay is getting the power the from that pin. So this was pin number 5 for my node. So relay has an input pin that I have connected to pin number 5 of my ESP8266. So whenever my pin number 5 turns on, It turns the relay on, and that's how it turns my bulb on. And then my lightsaber is turning on and off. It's very dim, but I can see my lightsaber turning on and off from this side. Okay, cool. So I'm guessing all of you had yes. Okay, I know it's fun playing with the lights. Don't worry about the link I have sent you guys. The link is temporary, so I'll be able to close it after the session ends. But cool. You guys got an idea. The document is there. It has all the detailed code and everything, so you guys can go through the code and learn about the code and write the whole thing on your own as well. Okay, cool. So, um, so bye bye. I'm going to end the session now. I'm going to first of all end the stream, and I'm going to disable the this link here. Bye bye.